Okay, today we're going to do lesson 8.1, and 8.1 is similar polygons and how to identify them. Okay, so some things you need to know before we start. A similar polygon would be that all corresponding angles are equal. And I'll show you what that means. Okay, just let you read the definition if you want. So similar polygon. They're similar if their corresponding angles are congruent. So see that this angle is congruent to that one, that's congruent to that, that's congruent to that, that's congruent to that. Therefore, these shapes are like dragging on like a computer screen, that they're similar. They're just expansions or contractions of each other. Okay, and then a scale factor. So a scale factor is a number which scales or multiplies the quantity. So I have an image for you here for scale factor. So we've determined that these are similar because this 70 corresponds to that, 70 corresponds to that, and the 40 is 40. So now this side is corresponding with this side because they're in the same location. So they're corresponding sides because they're in the same location. So now you can see that my scale factor equals 2 because the second object is twice as large as the first. Okay, so it's a multiplier. Then we have corresponding sides and corresponding angles. So corresponding sides and angles are a pair of matching angles or sides that are in the same spot. So when we look back to our picture here, 8 and 16 are the corresponding sides, and then a 40 would be in the corresponding angles, this other 40. They're in the same location. Okay? So looking at this one, how can you tell if they are similar? So to tell if they're similar, you need to determine that the angles in the corresponding spots are equal. So measuring this, it's 120. If I measure this, it's 120. And then when I measure this, it's 120. I measure this, it's 120. Okay, so you can see, I'm just going to continue that pattern. This happens to be that they're all 120. So they are similar. All corresponding angles are equal. So now what's the scale factor? So now we can take a ruler. I'm going to measure this. So I'm going to go 22 millimeters. And then I'm going to go here. And it's 40 millimeters. So I'm going to go 40 divided by 22. So 40 divided by 22. And my scale factor is that this object is 1.82 times larger than this object. Okay. Now, number 2. These two polygons are similar, so they've already told us that. Now label all the corresponding sides and angles. So now I can see that this angle is equal to that one. Let's use numbers here. 1 and 1. So this is a rotation, right? So that would be equivalent to that one. 3, and this is 4, and this is angle 5. And then, so those are all the corresponding angles with each other. So the side between 1 and 2, so this side corresponds to that one. So then the side between 2 and 3 corresponds to this side between 2 and 3. And between 3 and 4 corresponds to that. And this side corresponds to that side length. And then between 1 and 5, I'm running out of things here to write. Okay, so you can see all the corresponding sides. So if I go from 1 to 2, oh man, that's about 19 millimeters. And 1 to 2 is 46 millimeters. So 46 divided by 19 means that it's a scale factor of 2.42 times bigger. Okay, so now let's just try another one here. Let's go 3 to 4. So that measures 15 millimeters. So 3 to 4. So that's that one. Let's try this. 15 times 2.42. And I should have a length of 36.3. And you can see that. It comes out to 36.3. Okay, what if I now measure one here and want to get there? So let's go 1 to 5. So actually, no, I'm going to do 4 to 5 here. 27. So if I want to get to its corresponding, now this way I would divide, because I'm going backwards, I'm getting to the smaller one. 27 divide by 2.42 means 11.2. So this one should be 11.2. And it is. Okay, does that make sense? Just to take a note here, if you are ever like have a 6 and then a 3, remember that your scale factor is that it's getting smaller. So this would have a scale factor of 1/2, okay, representing something smaller.